Today we are going to learn about resting potential. Consider a resting neuron, that means an unexcited neuron. If we insert a microelectrode inside the neuron and keep another microelectrode outside of the neuron, and if we connect these two microelectrodes with a potentiometer or voltmeter, we will get a measurement that is called membrane potential or electric potential. Basically, this is the voltage difference present inside and outside of a neuron. In resting neuron, this is called resting potential, and the value varies between -40 to -90 millivolt in different neurons. If you see, you will find that the inside of the neuron is actually negatively charged and outside is positively charged. And the question is how this charge separation occurs. There is a sodium-potassium pump, and a potassium channel called resting potassium channel actually plays an important role. Now this channel, as because remains open during the resting condition of neuron, that's why it's called resting potassium channel. It is also known as leaky potassium channels. In another way, we call it potassium inward rectifier or KIR channel. Now this channel is actually non-gated ion channels. At first, ATP is break down into ADP, and by the hydrolysis of ATP, energy is utilized to export 3 sodium, and that causes the generation of sodium concentration gradient. That means there is a difference of sodium concentration inside and outside of a neuron. And as you can see, sodium is coming out of the neuron, so outside concentration of sodium remains high than inside. Simultaneously, this sodium potassium pump import 2 potassium, and that also generates the potassium concentration gradient. Now here, in case of potassium, the outside concentration of potassium is low and inside is high because potassium is coming inside of the neuron. Now the working of this sodium potassium pump is called electrogenic. That means by the working of this pump, it can cause charge separation. As you can see, 3 positively charged ions like 3 sodium ions coming outside and 2 positive ions like 2 potassium ions coming inside. So there is always excess positive charge will be present outside than inside. So there will be an excess negative charge left behind in the inside. So by the working of sodium potassium pump, charge separation occur. And one thing I want to mention that this sodium potassium pump only contributes 10% of the resting membrane potential. Now potassium channel, as because it remains open, so through this potassium efflux occur. Here one thing is very important, that through any open channel, ions show downhill movement. That means ion will move from higher to lower concentration. And as because the potassium concentration is higher inside than outside, so potassium efflux occur. And this 90% of the resting potential is generated by the potassium channel. Now one thing I want to also mention, that as because this potassium concentration is generated by the sodium potassium pump, so indirectly the sodium potassium pump actually helps in the generation of resting potential. Now as potassium moves outside of the neuron, so outside excess positive charge builds up and excess negative charge left behind inside. So that's why the outside of the neuron is positively charged and inside is actually negative charge. Now one point I want to mention here, that is electrochemical gradient. It is also called ion motive force. So the movement of ion is governed by the electrochemical gradient. It contains 2 parts. One is the electrical part called voltage gradient, another is the chemical part, the ion concentration gradient. So in case of potassium ion, as during the resting potential, the outside become more positively charged, so the efflux of potassium is actually prevented. But as the ion concentration gradient is such that the inside of the potassium ions is higher than outside, so potassium efflux actually promoted. So these 2 opposing force, the voltage gradient that opposes the efflux of potassium and the ion concentration gradient that promotes the efflux of the potassium, are 2 opposing force that works on these potassium ions. Now at a certain membrane potential, the two opposing forces just balance each other, and there will be no net movement of potassium ions that occurs in the resting condition. And this potential is called potassium equilibrium potential. That means here the voltage gradient and ion concentration gradient just equilibrate. If you put the value of potassium ions that is present inside and outside the concentration into an equation called Nernst equation, you will get a value that is very close to the resting potential, that is -70 to -60 to -70 millivolt. Okay, now I want to mention one information that in the neuron, not only these non-gated potassium channels are present, but there are few sodium channel. These are all non-gated. Calcium channel and chloride channels are also present that remains open. So the resting memory potential is predominantly generated by the potassium. So through the potassium, non-gated potassium channels, potassium efflux occur, and through the non-gated sodium channel and calcium channel and the chloride channels, these ions actually come inside of the neuron. Hope this video will help you. If you have any doubt, you can write me in the comment section. Thank you for watching, and always keep learning.